Hello everyone, I'm Liu. Today I will talk about the regression analysis on the Medicorp dataset. First, let me give you some background. Medicorp is a company selling medical supplies in three regions of the United States: the South, West, and Midwest. And the company carried out a new bonus program, and the managers want to see if the program works effectively. So our goal is to find out if there's some relationship between sales and bonus. We also take advertising and region into consideration. Dataset includes three numerical variables: the sales, which is Medicorp's sales in each territory. Advertising is the amount Medicorp spent on advertising in each territory. Bonus is the total amount of bonus paid in each territory. There is also one categorical variable, region. The region is coded into two dummy variables, D1 and D2. So there's five total variables, and the dependent variables is sales, and the independent variables are advertising, bonus, D1, and D2. First, let's run a regression model with two independent variables, advertising and bonus. As we can see here, the adjusted R-square is 0.842 and the regression standard error is 90, and the p-value for both independent variables are very small. So this model is not bad, but we still want to add region information into the model. Let's run another regression model with advertising, bonus, D1, and D2. As we can see, the adjusted R-square is increased and the regression standard error is reduced. And the p-value for advertising and D1 is very small, but the problem is that the p-value for bonus and D2 is a little bit high. So we may want to know if the bonus and D2 are useless or they are causing overfitting problem. So we need to run a nested regression model to see that. Here is the result of the nested model F-test. The nested F statistic is 3.755, which is significant because its p-value is very small. So this means the bonus and the D2 indeed provide useful information, and they are not gonna be reduced, and the complete model is favored. And then we want to start to check for influential points. First, let's see the outliers. All the students had the residual within -3 and 3, so there's no outliers with unusual y value. Then we can see the leverage. The highest leverage is the observation number 11. It's 0.373. So it is still smaller than the average threshold. So there's no influential point with high leverage. Finally, we will take a look at the Cook's distance. The observation number 11 has a Cook's distance greater than 0.5. This means we need further investigation to see if it is an influential point. So we remove observation number 11 and regression. Recall that in the previous regression, the p-value for bonus and D2 are somehow high. Now you can see all the p-values for the four variables are very small. The p-values change dramatically. So observation number 11 is an influence point. We need to remove it. Also here you can notice that the VIF values for all variables are lower than 10. This means there's no multi-collinearity problem in this model. After removing the influential point, our model seems good enough. So here we start to check the four assumptions. First, we create a scatter plot with regression predict value on the x-axis and the regression residue on the y-axis. Here we can see the residues average out to 0 as we move across the plot from left to right. So 0 mean assumption holds. And the vertical variation of the residue is similar as we move across the plot from left to right. So the constant variance assumption holds. There's a small problem about the independence assumption. So you can see there is a slight pattern in the scatter plot, but we believe this is caused by too few observations. And here is histogram and QQ plot of the residues. So you can see that the residues is very close to normally distributed. So this means the normality assumption holds. Here is the predictor effect plot. This plot shows how sales value change as we change each individual independent variable. We also did some further analysis on transformation and interaction. We tried to add interaction terms like D1 times advertising and D2 times advertising. We also tried some transformation like adding the quadratic terms, use the log transformation, and use a reciprocal transformation. But all of these transformations and interaction has no improvement for our model. So at last, we reached the final conclusion of the regression model. That is, the sales is equal to 211.99 plus 9.96 times advertising and 1.542 times bonus and 314.448 times D1 and 60.58 times D2. Thank you.